All right, so funny story. Uh, I actually already recorded this, but my video recorder decided, microphone. Why would you need that? And it, excuse me, muted it. So I am going to be starting over. Yay for that. All right, so this is going to be try. It's going to try and be as short as I can make this. Um, some of my friends are going through more advanced programming, um, so they need to know, binary, that sort of stuff. And I already taught this to them, but in case they forget and I'm not here, they can, look at the video and refresh. So, uh, before we go over binary, we're going to understand why we need it. Now, you and we could understand a base 2 system, uh, the base 10 system, whatever, base, you want to put. I mean, base 3, it doesn't matter. But a computer, or rather computer components, they only understand two possible values. Now, those two possible values can be whatever you want them to be. They could be 0 and 1, or A and B, Z and F. It doesn't really matter, but they basically indicate two possible values. In most cases, it equals either true or false. So, first thing is the bit. All right, so the bit is either 0 or 1. And that's the only thing computers can understand. I mean, they don't understand a 3, a 2, they don't know what the hell it is. So basically, what we have to do is we have to do something um, so that the only thing a computer can recognize, which is the base 2 system, and we'll go over that in just a second, we have to convert the base 2 system into something that we can understand, which is the base 10 system, because that's what we were all, you know, brought up to, understand. So, uh, starting out, we have a bit which has two possible values, 0 and a 1. All right, so that's all well and good. We can have true or false, but I mean, what kind of math are we going to be able to do with 0 and 1? We can't do 1 plus 1 because that's 2. We go over. Uh, so, we can do 1 plus 0, which is 1. 0 plus 1, which is, 1. 0 plus 0, is 0. That's pretty much all we can do. Doesn't really help us out much. So, we have to, you know, extend it. And that's what we need the base 2 system for. So extending out, the next thing we're going to be going over is the nibble. Now, what is the nibble? The nibble is basically let's see. If I was to write a nibble form in the base 10 system, it could look like 9999. All right, because we have, 9 possible, digits, or I should say, character uh, representations. So in the base 2 system, this can look like, this or this or this, any of the possible combinations. And each of these possible combinations indicates a different value. And that can sound kind of complex for the moment, but later on this will make more sense. And I'm not going to put all of the possible you know, values that nibble can do right now because, you know, we don't need it here. It's just going to be long, and if I did that, I'd also have to do it for the next thing, which would take even longer, way longer. So the next thing we'll be going over is the byte. And the byte is two nibbles put together, or 8 bits. So the byte would be like 1, 1, 1, 1, 1, 1, 1, 1. Okay, so that's a byte. Now, each of those ones could either be ones or zeros, depending on what number we're trying to represent. All right, so we have the bit, the nibble, and the byte. So looking at these, I will go more over this in a sec, but the bit has 2 maximum combinations. The nibble has 16, and the byte has 256. All right, so we're going to keep that in mind. A little bit, you're so helpful. Wish I could deck the person who had the idea to put this thing so you put it close to the top and it's like, oh, you want to extend it to the whole screen? Yes, yes, that's what I was trying to do. I obviously wasn't just trying to put it as far over as I could so I could place more shit on the screen. Alright, well anyway, wasting time. Alright, so let's see, what was it going over? Bit has 2 possible values, nibble has 16, the byte has 256. Alright, so the next thing we're going to be going over is the base 2 system versus the base 10 system. And let's see, we're going to get another notepad here. Alright, so we're going to, I'll put this down here. That's where I had it last time. Alright, we're going to increase the font size just like that. Alright, so this is stuff that you probably went over when you know, school early on. And essentially we're going to be doing the same thing here. So we're going to understand first that the base 10 system, it has 10 possible, you know, representations. So 10 possible values can be for, you know, one character. So you know, after we reach that highest, we have to add another one, otherwise we can't go any higher. So what we're going to do then is we will have 1. 1 is always going to be the start of any base number system. It has to be. All right, so this is also going to be the only bit that will represent whether our value is even or odd. So if you're doing programming where you need to know that, you know, some programs do, you know, depending on what you're trying to do, that is a simple way. All you have to do is look at the first bit rather than doing fancy calculations to see if it's divisible by 2. You know, optimizations and shit. But I'm going off course, so I'm going to stop myself before I do that. All right, so 1 is our first, and it will always be our first for any base number system we use. Since we're using the base 10 number system, we need to look at how many possible values can we have for each character. And since we're using the base 10 system, there is 10. there is 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. There's no 10 because 0 counts as a unique, character in the base 10 system. All right, so starting out at 1, we need to find out what the next, number that's needed is. So, this isn't right, but I'm just going to show you just really quick here. If we did 9, as our next, then we're actually losing one of our possible character combinations for that slot, which isn't just one character, loss. I mean, one value loss. It's a lot more, depending on what you're doing. All right, so I was going to show all that stuff, but I'm not going to have time. So we're just going to get right to it. All right, so 1 is going to be multiplied by what a base it is, and it's a base 10 system. So we're going to start out here, 1, all right? Always our first for a base number system. 1 multiplied by 10, which is 10. Now from there, we're not taking that 1 again. What we're actually doing is we're taking the current highest value of the previous, and we're going to be multiplying that by our base number. So since it's 10, we're going to be taking this value, 10, multiplied by what? 10, because it's a base 10 system. All right, and that's what? That's 100. All right, so 10 multiplied by 10 is 100. All right, and then we move on. 100, oops, come on. 100 multiplied by 10 is 1,000. And, this just goes up and up and up in the same fashion. So we're going to write this down really quick, and I'm only going to go 3. So what we'll do then is we will do, hold on. No. Wait. Alright. Alright, so we're going to be starting at our lowest first, and what we need to understand is that we can have up to our possible values for our base number system on this right end here, or left end if you want to reverse. It really doesn't matter. Both multiplies the same way, but that's the way I'm going to do this so I don't confuse people. All right, so this one here is actually this one right here, or this one, I should say, because it's going to be on this side, not that side. They're both the same, but yeah, 1. All right, so that's going to be our 1. Now, let's say if we're using a base 10 system, I'm actually going to leave this open because it's going to be in the way and I don't need it, but really quick here. So, the base 10 system we went over 0, 1, 2, 3, 4, 5, 6, 7, 8, or 9, right? So that means each of these can be a different, value. That means with just this, we can have 10 possible, 10 possible values. I mean, this doesn't have to be numbers. It could be 0 is fish, 1 is cats, these could be types, or, whatever you need it to be. But all you need to really understand for now is that whatever you're using this as, you can only have 10 possible types. All right, and what we're using this for is, our base 10 number system, so it's going to be numbers. So keeping that in mind, get rid of that. In here, we can have, I'll bring it back really quick. In here, we can have one of these to indicate a value. All right, so we'll say, 3 is highlighted. We'll use 3. All right, so 3. And we're going to move on to the next one here. And you saw that this is multiplied by the base 10. So the next one here is 10. All right, so 10 multiplied by, we'll say, 5. All right, so 5. And our next one here is going to be, come on, our 10 multiplied by 10, because we're taking a maximum value and we're multiplying it by the base's highest amount we can have. So 100. So 100 multiplied by, we'll say, 8. All right, so a lot of you probably in school saw it written like this. I don't actually use those because I'm a programmer and that's, it's not what we use, but it's what a lot of people, saw it as growing up. So, looking at this, 1 multiplied by 3 is 3, okay, plus, in parentheses here, so, these are all done first. 10 multiplied by 5 is 50, over here. 100 multiplied by 8 is 800. All right, so what do we have here? We have 853. 853. All right, so, we've used this system to, get a number that we can read and understand here. All right, in that same way, we're going to do it with our base 2 system. All right, and this is going to work a little bit different because we don't get all of this. What do we get? We get this. That's all we get. That's all computers can understand. Zeros and ones, or A's and B's, or whatever the hell you want to reference it as. It could be 2 possible types. You could have fish or cats. Whatever it's representing, it can only be 2. All right, so the base 2 system. How is this all going to look compared to the other one? All right, so it starts out the same. Always going to be 1. So, 1. Whoops. All right, 1, 1. And remember what we do is we take the previous value, which is this one. So 1 multiplied by what? The base number. So the base number is going to be 2. So 1 multiplied by 2 is what? 2. Ahem. Fucking keyboard. All right. Oh, sorry, language. 1 multiplied by 4 is... Oh, I'm getting ahead of myself. I am sorry. Okay, 1 multiplied by 2 is 2. All right, so moving on. They're doing 1 multiplied by 4. That's not even right. All right, so we're taking the previous number, 2. 2 multiplied by what? The base number. Base number is what? 2. Since we can have 2 possible values. All right, so 2 multiplied by 2 is 4. All right. So moving on. 4 is our previous. 4 multiplied by the base number, 2, which is 8. 8 multiplied by the base number, 16. And then 16 multiplied by the base number is 32. And then 32 multiplied by the base number is 64. And then, you know what, I'm gonna do a byte. So 64 multiplied by the base number is 128. Alright, so you see here that we have something similar to what we have here. Although this is a lot longer than this because I didn't write, all the way out. If I was going to write all the way out, this would be 1,000 multiplied by 10 is 10,000. And then 10,000 multiplied by 10 is 100,000. Just going up and up and up, But we don't need to do that because you guys should already know the base 10 system. All right, so looking up at this, the same way we did this, we have to, add in the same way and do the multiplication. So we start out at 1, so 1 multiplied by, we'll do the, no, we can't do the same one, so what am I doing? I can only do zeros or ones. Oh, such a tough decision. I have to use a 1 or a 0. Which one? Which one? We'll use a 1. Use a 1. Alright, so 1. Alright. That means our number is going to be odd, whatever it is. Alright, so that's our first one. And this right here, that's what this is. And this right here is either this or this. Alright, so moving on. Our next place. We're going to have a 2 here. So that's our next one is 2. I keep wanting to put that by instinct. Alright, we're going to say this one's a 0. Alright? And as you can see here, I can also put this in a different way here. So understand 800 plus 50 plus 3. In that same way, 850 and 3 is equal to 853. Alright, so in that same way, we're going to be doing the same exact thing in the base 2 system. Alright, so oh, I love this keyboard so much. Alright. So for our next place here, this will be our third place, which is going to be a 4. So 4 multiplied by, and we'll say 1. And we're going to do one more here. This will represent our nibble. And our last one here is going to be an 8. So 8 multiplied by, we'll do, we'll do 1. We'll do 1. Alright. Alright, so what we've written out here is the same thing as this basically. And so it's going to work the same way. We're going to have 1 times 1, which is 1. So it's going to be what? 1 plus what here? 2 multiplied by 0. Multiplied by 0 is always going to be 0. So plus 0. Move on to here. The next one, 4 multiplied by 1. Going to be 4. And then, oops. Come on. The last one here is 8 multiplied by 1, which is 8. Alright, so what do we have here? Converted to our base 10 number system, this is what? That would be 12, 13. Alright, so 13. Alright, so it's equal to 13. That actually wasn't a keyword, I actually mistyped on that one. Alright, so 13. Alright, now how would this be written in the base 2 system? Well, we got a 1 here, we got a 1 here, we got a 0 here, and we got a 1 here. So, written as a nibble, this would be 1, 1, 0, 1. Alright, so, we can also go backwards with this. So, 1, and it's a 1's place, so 1, and then 0. So that would be 0 multiplied by 2, which is 0. And then this is the 4's place here. So 1 multiplied by 4, that's 8. So total right now we got 8, and plus 1 is 9. Alright, so we got 9 so far. And then going to the next one, which is the 8's place. Did I just say 9? Oh, I am way off. Sorry. We're gonna retrace because I was actually wrong. This is what I get for doing this late at night. Alright, so this is the 1's place, this is the 2's place, this is the 4's place, and this is the 8's place. I don't know what I said before, but I was not right. Alright, so the 1's place, 1, the 2's place, the 4's place. So 4 multiplied by 1. So this is actually 5. I don't know what the hell I was doing. Alright, so adding the next one, which is the 4th place. So that would be 8. So 8 multiplied by 1, 8. So currently we have 5 here and 8 here, so that would be 8 plus 5, which is, once again, 13. Alright, so, yeah, I don't know what the hell I was doing before. Alright, so now we're starting to understand a little bit more on how this works. So, now that we understand just a little bit more about it and how it all goes together, there, we're gonna do a little bit more, let's see here, get you out of the way, you're in the way. Actually, you know what, I'm gonna use you. There you go, became useful. Alright, so, as you saw before, we have, right, the 2 here, base 2 system and base 10 system. Alright, so, as you saw, both of them always start out at 1. So 1. Alright. So we're going to do the base 10 system first, actually. Now come on, there you go. Alright. Alright, so we have 10 possible values that we can get before we get to here. Alright. So we're going to be counting up to understand a little bit more about how the base 2 system works compared to the base 10 system. So what we're gonna do is put this right here. Did I put this on the right one? No, I didn't. I want that one. Alright. Alright, so we're gonna start at 0. Alright? 0. So 0 and 0. That is, 0 for both of them. Alright, so now we can move on to 1. All right, so 1, 1. All right, so now our value is 1, and everything's, all well and good. All right, so now we go 2, and wait a second. This can only have 2 possible values. So this can't be 2, because, that would be 3 possible values. There's 0 and 1. So we can't use 2, so in the same way of the base 10 system, we're going to have to carry to the next place. All right, so we're going to set this to 0, and we're going to move this to here. I'm going to put it on the right line, though. All right, so now you see here that our value is 2 here, and our value is 2 here. All right, cool. All right, so now the base 10 system, 3. All right, so 3, and we go up here, say, okay, increase. There we go. So now we have 3 in the base 2 system. All right, now we're gonna do 4. All right, so we go. Wait a second here. This is already the maximum possible value we can have. So in order to go any higher, we have to add another place. All right. So to get to 4, we have to carry. So 0. Then we're carrying this over here, but it's already too high. I can't go any higher. So 0, and over here on the right line, 1, and that is 4 in the base 2 system. All right, we're moving along. All right, 5. So go ahead and add another here. There we go. Always starting out here on the right, and going to do 6, and we're gonna see that this can't go any higher. It's either 0 or 1, so obviously we got to carry over here. All right, now we're at 6 in the base 2 system. All right, so now we're at 7. 7. All right, there we go. Now we have 7 in our base 2 system. Let's go 8. All right, all cool. Let me go up here. See, we can't go any higher. We gotta carry. Can't go any higher. We gotta carry. We can't go any higher. We gotta carry. Oh, that means we need another one. All right. So we put an 8 here. Go ahead. This is extending farther than I thought it was. So we're gonna carry that 1 over and put it here. All right. So now we have 8 in the base 2 system. All right. So all well and good. 9. All right. 9. There we go. We have 9 in the base 2 system. Counting up by 1 on both of these each time. Now we go into here and we go, wait a second, we can't do 10, can we? So, we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have to, carry over. So, 0, and then we put a 1 here. All right. So now we have 10 in the base 10 system. So in here, we can't go any higher here. So we're going to carry. There's a 0 here. This can go higher, so we'll put this here. All right. Now we have 10 in the base 2 system, and 10 is the base 10 system. All right. And moving right along, we have a 1 here. All right, 11. All right, all well and good. Now we got to increase here. We see here, this can go higher, so put it right there. All right. And we're going to go right along. 2. So 12. All right. And moving up here, we see that can't go any higher here. Got to carry. Can't go any higher here. We got to carry. And this can go higher, so we'll put it there. All right. There we go. 12. All right. So moving right along. We're going to do 13 now. 3 in the 1's place. 1 in the tens place, 13. All right. And we can put this right here, you know, go higher, so we're good. All right, so we're along, 14. Can't go any higher, we got a carry. All right, and go 15 here. All right, and there's no sting here, so let's put it right there. All right, so as you can see, you know, we're counting up in the same way, and we have to carry in the same way as the base 10 system. It's just different numbers that we're working with. So, as you can see, you know, if you've been paying attention to the details here, we started out at 0. So, you know, 0 counts as a possible value. And as you can see here, we have 15 here. So if 0, you know, is a value, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15, that's 16 possible values. So, you know, we could have each of those represent, you know, a type or, you know, a different number, you know, whatever you want it to represent. But each of those can, you know, represent one thing. All right. So now you see here, 1, 1, 1, 1. That's the highest possible value we could possibly go in a nibble, which is 4 bits. All right, and you see right here, I put a 16 here. Remember, a bit can only have two possible values. A nibble can have 16, starting at 0 all the way up to 15. All right, so now we've done it in, you know, a base 2 all the way up to a nibble. And as you can see from here, it, you know, it goes up in the same fashion all the way up. So the maximum possible value, if you want to determine how many possible values you can have, you basically just take all of these numbers here on the right and you add them all together. So rather than think, we're going to do 128 plus 64 plus 32 plus 16 plus 8 plus 4 plus 2 plus 1. As you see, our maximum value is 255 here. But remember, 0 is also a value. So we can have how many? 256 possible combinations in a byte. So here we've gone over some basics for binary here, and I don't know if I will do the next lessons. The next lessons are going to be, you know, a little bit more advanced, more going into programming. But I just wanted to basically get this out here, you know, in case my friends forget, you know, what I taught them, you know, and I'm not there, you know, they can look this up and, you know, read how it works. So, you know, now knowing all of this, you can look at binary and you can actually read what, you know, what the value is. It's not going to be like right off. You're not just going to be like looking at it and be like, oh, you know, that's blah, 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 you know. I mean, you have to do a little bit of calculation. I mean, it's, you know, it's a lot easier, you know, using our base 10 because you don't need to convert it, you know. It's, it's already what we use, so it doesn't need any different representations. So since it's a different representation that needs to be converted to the base 10 to be able to be read by us, it's a little bit more difficult. But no, I hope this has helped you understand a little bit more, at least, about binary. Back when I learned binary, I was doing a lot of teaching myself because people would say it's 1, 2, 4, 8, 16, 32, 64 to 128. And I look at that and I was like, okay, cool. But then you look and it goes farther and farther and farther. This is 1 byte, that we've gone over here. But most things nowadays use a 32 bit, which is basically a 4 byte integer, and that goes much higher, and it's a lot harder to remember these numbers without knowing exactly what happens to these numbers, why they're incrementing the way they do. So nobody actually taught me any of this. I actually, over time, I had to teach myself how these things worked, in order to do what I wanted. So yeah, that's where I learned this stuff, and this is basically what I've come up with on the best way to explain how binary in the base 2 system works. I mean, if you look at the tutorials and they just say, oh, it's 1, 2, 4, 8, 16. I mean, sure, you could try and remember that stuff, but I mean, what if you forget one? It's like, whoa, wait, what was this? Was this 128, 126? I mean, if it's not exact, then you're going to have the wrong value. So, I mean, if you know how to go back and, you know, figure out how it works, then it's a lot easier to, understand this stuff. But yeah, this has been, simple binary. We learned 3 different types: bits, nibbles, and bytes. I will ask my friend if he wants me to do the other uh, tutorials for the more advanced ones. And if he wants them, I can do those too. But yeah, I think that's pretty much all I need to teach here. So I think I'm going to cut this off here. Alright, yeah, we'll cut this off here. Alright.